All right, well, we are close enough to 12:30 Eastern time, so we'll go ahead and get started. We are recording this webinar. My name is John Mann, and I'm an assistant professor here at Michigan State University, and I host this series, Innovations in Agriculture and Rural Development, which is sponsored by the North Central Regional Center for Rural Development. So I want to welcome everybody to today's webinar. Our topic is NVision Ag, increasing corn yield and saving nitrogen fertilizer. So before we get started, I just want to point out a couple of things real quick. So first, if you haven't done so, please take a moment and answer our poll questions, especially question number 1. That kind of helps us track our audience and know who is participating in our webinars. Second, down in the chat box below, there are a couple of items already in there. So one is my email address, one is Peter's email address, and the third is our YouTube channel. And so that's where you can find a copy of this recording. And so I'll get it up there later on today, but it'll be up there by tomorrow morning for sure. Also, when you've got as your questions come up, we're going to use the chat box to manage our question and answer session. So go ahead and type your questions in there as they come about. So finally, our presentation should be about 25 minutes-ish, and we'll have about 15 to 20 minutes for questions and answers. And so again, as your questions come up, please put those in the chat box. So I want to thank everybody for joining our webinar today. I'm going to change screens real quick, and then I'm going to pass the mic off to our presenter. So Peter Scarf is a professor in the Division of Plant Sciences at the University of Missouri, and he's going to talk today a little bit about his work increasing corn yield and saving nitrogen fertilizer. So with that, Peter, the floor is yours.
Thank you, John. Really appreciate the invitation to be on part of your series. I guess I'll start by saying, looking through the list, I see that Allison from Farm, well, I'm sorry, I've forgotten that, and Paul Carter and Phil Cochran are on the line, so hello to the three of you. This work stemmed out of research I did at the University of Missouri, and NVision Ag is a startup company that I started to try to get this technology into the market. The university has the patents, and I am licensing those from them. So I'm wearing two hats today, and they're both on at the same time, kind of stacked on top of each other. But the thing that we're aiming for with this in terms of where is the payoff is with increasing yield or saving nitrogen or both. There's a couple things here that one of the things is this is kind of a new innovation. That's why it fits well in this series. I think that looking into a 10 or 20 year horizon, that this kind of approach is going to be common because both economics and environmental concerns are going to drive us to do a better job with nitrogen than we're doing today. And to do a better job, we've got to have the right data, the right numbers. We've got to understand what they mean. We've got to not be biased in how we interpret them, and know what's reasonable and not reasonable. So there's a lot of things that go into making a good system that can give you the right answer. So I said technical expertise in the last slide. This is a manual that I wrote from condensing a 1,000-page, 23-chapter book on nitrogen. And so there's 2 points here. One is that I know a lot about nitrogen. It's the main thing I think about. And the other one is, if you look at the color of those plants, that's really what this whole technology is based on, is the fact that plants with plenty of nitrogen are dark green, and plants that are extremely deficient are a light yellow green. And you can quantitatively measure that and relate it to things that you actually care about. So I said that we could increase corn yield, and basically that means identify places where nitrogen is limiting the corn yield. That can happen 2 ways. One is it can happen because we put the nitrogen fertilizer down and then it was lost, which is usually a function of wet weather. The other is that the nitrogen need was just particularly high in a year or a field or a part of a field and above the farmer's normal rate. In most fields, the amount of nitrogen that's needed varies widely from one place to another. And so if they get in the middle, they're going to have both under and over application in the same field. And that is an opportunity to go higher where the places that need more are located, but also save fertilizer in the places where the soil is chipping in more. And we can get by with less. So there's 5 basic science points that I'm going to try to cover here as we head toward how do we actually put together a system and make this work, to kind of give the underpinnings of why it matters and why we can use this for the benefit of the ag enterprise. So the first fact is that nitrogen is lost in wet weather, and that's true both for fertilizer nitrogen and for soil nitrogen. A lot of people don't appreciate that even before mineralization kicks in, most soils are going to have 50 pounds of mineral nitrogen, nitrate, and ammonium sitting there ready to contribute to crop growth, and if that's lost, it impacts the nitrogen status of that plant just as much as if fertilizer nitrogen is lost. I already mentioned with the picture a couple slides ago that nitrogen deficient plants are lighter colored, and so I've found that we can take that crop color and do a reasonably good job of predicting yield loss and also predicting nitrogen need based on that color. When you're looking at a loss situation, replacing that lost nitrogen is very profitable, but if you replace nitrogen that wasn't lost, you spent on an input that's not going to return. And finally, most cornfields have both under and over application of nitrogen fertilizer because they're getting a flat rate when the need is anything but flat. So I'll go through each of these kind of to support it, but quite briefly. Now there's a couple other pathways that nitrogen is lost, but basically by far the dominant thing is excess spring rainfall, and depending on the drainage class of the soil, you may get leaching, you may get denitrification. It depends on timing and weather, and soil temperatures are very important for denitrification. And I'm going to give you a couple example fields where we measured how much was lost and related it to the pictures. And they're both from 2009 when it was wet in the southern corn belt in the cross-hatched blue areas that you see. And one example is in eastern Illinois, the other one is in western Missouri, and both of them are in areas that had excess rainfall that year. And the Illinois field had a bunch of parts to it with trees in between, but the western part of that field, if you look at the aerial image, that part of the field there is the darkest except for this little spot here, and you'll see that's where the 200 bushel yields are. Red is 200 and up, and that's the only part of the field that has that 200 and up, and where that light spot is, it's down below 120. The lightest part of the field in the aerial photo is the one that's farthest to the north, and if you look at the yield map, it's the one that has the most blue in it. And when we compared color to yield, we found that, okay, the darkest green corn was yielding 173, and the field average was 139. The light colored corn, of course, was much lower yielding. A lot of it was below 100. So field wide, the average yield loss due to deficiency was 34 bushels. That year, 370 was a pretty average price. You're looking at $126 an acre. And for a lot of you, you understand the scale of that and that's quite a lot of money in grain production. Here's another example, and I personally took this photo, and I was able to find who's farmed it, and he shared his yield map with me, and it got 150 pounds of nitrogen per acre at about Thanksgiving time. And this is a photo taken the next August, and you can see it looks awful yellow and not the color that you want corn to look at all, with a few spots up on the knolls where it's darker and not as much water there. And in this field, average loss was 45 bushels per acre. He had 170 up on the knolls and 80 down in the yellow drainage type wetter areas. And field average was 125. It's a 265 acre field. He came out losing $45,000 in that field due to deficiency. This is a very well drained soil, so I'm sure none of this was sometimes when the corn turns yellow, it's had damage from too long oxygen deprivation, and it can't completely recover. But in a very well drained soil like this one, I'm pretty sure that that didn't happen, and all that yield could have been recovered by supplying the nitrogen again that had been lost. So over the past 10 years, I would estimate 3 billion bushels, probably more than that. I mean, just from 2008 to 2011, I estimated 2 billion bushels, and 13 and 15, there was a lot of yield loss in those 2 years as well. So these estimates are based on about 6,000 miles of windshield surveys in August and a whole lot of aerial photos. And going out into a field that I thought was going to lose 80 bushels, standing there in the field, I still thought that. So there were a lot of fields that were really held back by nitrogen. Now, if we could predict that in June, in time to do something, and the question of whether it's in time to do something is still open, and some people doubt that, but we'll get to that next. If we could predict it in late June, then we would know how bad is this problem, and do we really need to do anything about it or not? And when you're sitting in the coffee shop trying to guess, you may be pretty far off. So here's an example of one of the fields that our algorithm is derived from. It's in Illinois, and we got the image and we got the yield map, and the graph on the right shows for that field what the relationship was between the color. So we cut it all up into like a checkerboard, and for each square we measured the color and the yield, and then we said, okay, how did that relate? And there was a strong relationship that as the corn got lighter and lighter, which makes this relative green a higher number, the yield loss got higher. And so we combine across many fields to get a robust equation that works over all the fields, and then we use that to predict in future fields what the yield loss is going to be or the nitrogen rate. And we had a lot of separate experiments with nitrogen rate treatments and imagery, and we can predict the nitrogen rate that's going to make the most money from the color of the corn at this time. So if you know that it's not the right color, can it still be fixed, and how long can it be fixed? The latest I've ever applied rescue nitrogen is tassel. I had one field where we made 80 bushels in response to nitrogen applied at tassel. How much after tassel can you go? I'm not sure. In this field, it was applied probably a week before tasseling with a sprayer with drops on it, and you can see some very distinct stripes in part of the field. And that was due to, they did 100 feet width, putting down, let me think, what was it, 12, 14 gallons of 32% with drops, and then they'd skip 100 feet, and then apply 100 feet and skip 100 feet. And in the places where you can see the stripes, the difference between the dark stripes that got the extra nitrogen and the light stripes that didn't is 30 bushels. But in the places where the stripes disappear because the corn is not yellow, even though it didn't get extra, they did not make any extra yield. And so my short rule is if you can see it, it's money, and if you can't, it isn't. Now, I have seen a couple times where you could get a profitable yield response and it didn't look that stressed, but it was not big, it was small. And in general, every time I see a lot of stress, I've seen a profitable yield response. So if you are aware that nitrogen is lost in wet weather, and I think we're to the point where nearly everyone in the ag enterprise does do that, what should you do? What can you do if you suspect nitrogen loss? And let's start with, if you suspect nitrogen loss, that means you don't know. You're suspecting. And that's not really a very good basis for a decision. We currently actually still have, when it rains a lot and people are worried about this, the dominant response is still to do nothing. But it used to be that maybe 5% of farmers would really make an effort to get more nitrogen on, and I think that number is up closer to 40%, maybe higher by now. What is it that they do when they decide they're going to do something? It's mostly shoot from the hip, and that means put 50 everywhere in general. People who are signed up for the models like Adaptan, FieldView Pro, and Circa can use those as a good tool to help evaluate their suspicions. My understanding is it's pretty hard to get a whole bunch of fields signed up in June if you haven't already signed up prior to the season because of the time that's involved. And the reason I'm showing you this picture, this is in northern Iowa in 2014, is to make the point that putting 50 everywhere is not the right thing to do. And that is the dominant response among people who do something at this point. So in field 1, 50 is still going to leave you way short of that field's potential. In field 2, 50 is probably not too far short in the eastern part of the field, but is wasted in much of the western part of the field where the corn looks a lot better. In field 3, putting 50 on everywhere would be something you'd have no chance of getting your money back on. And in field 4, there's places that need 0 and places that need 150 within a stone's throw of each other. And so putting 50 everywhere in a situation like the one shown here is a lot better than doing nothing. There's other places where you get quite a bit of rain, but a lot of it ends up running off because it fell so hard and it doesn't infiltrate and it doesn't affect your nitrogen. And you could put 50 everywhere, and the problem would be that you actually lost money on that proposal. In this scene that you see, you'd make money on the proposal but still leave yourself short overall. But in some cases, you'd be going long with 50 just because it rained a lot. So the problem with the picture that I just showed you is I took it from an airplane. I had a beautiful day. Sometimes you don't get a beautiful day. And sometimes you don't get a beautiful day for 3 or 4 or 5 or 6 days after you wanted to make that decision. And so that was my experience in my first couple of years of running NVision Ag, was that waiting for the planes, we took us an average of 4.5 days to get the image from the time the order was placed. And so last year, we switched to satellite imagery because suddenly these little satellites were getting 5 images a week. And the first month they were doing that was June of 2017. And so I think for something like making a nitrogen application based on a satellite image or an aerial image of some kind, you really need to have it when you need to have it, and people cannot really wait around for that to show up. So I'm very excited about using the satellites to do this because with 5 a week, what you do is when the order comes in, you look for yesterday's satellite image, and if it was cloudy yesterday, you look the day before. Planet Labs put up 88 of these little satellites in February last year, and they already had a bunch up there, but it changed their game in terms of how many images they could deliver. And last year we did not fail to fill any orders we always found a satellite image in the past that was suitable for making our products. So that sped us up a lot, and we don't have it completely automated yet, but if we can get that automated with the satellite company, I see it being faster yet. So what you have in that situation is a photo, and for us, you look at the photo and you pay for the image, and you haven't paid for anything else yet. If you decide, I see a potential problem there, you can order a yield loss map, and it will tell you how big is this problem? What's your average yield loss? What's your total for the field? What's your total dollar loss in the field if you don't do anything? And that gives you a real metric to use in making a business decision about buying more nitrogen and the application service to get it on there. In some fields, you're going to look at it and it's dark green, no problem. You can move on to the next problem that needs to be solved. But if you see numbers like the ones here, you probably for sure should be doing something. And really what you should be doing is putting a lot of nitrogen where a lot was lost and not putting nitrogen where the first shot is still there. So this is a visual on the right of the screen showing the plan for what the rate control file will do. It goes into a machine that can execute it. We're working right now on developing these for planes. I've got 3 customers are interested in doing it with planes this year. We haven't done that before. and we have to change the control files a little to optimize them. But this is a bunch of electrons that go in and run the computer in some kind of applicator and put a high rate where a high rate was where a lot was lost, and a low rate where the original nitrogen is still there. So that's the loss situation, and you're trying to get the nitrogen rate right, but there's more to getting nitrogen rate right than did we lose it or not. There's a lot of complexity going on even without that happening. One thing is that the weather has a huge effect. The soil has a huge effect. So there's all this talk about the 4 hours, and the right rate is probably one of the most important ones. But it varies widely year to year, field to field, and place to place within a field. And that means the flat rate that most fields get is both under and over applied. And I'll go through those quickly one at a time. Here's an experiment from Illinois where the most profitable rate was 85 in 2014. This is a little small plot experiment, maybe an acre in size. The next year it took 165 to be the most profitable. The next year 100, and the fourth year 170. So what's going on with that? Is it that yields were higher in the yields that needed more nitrogen? And the answer is no, that it was 200 to 220 all 4 years. And it was weather driven. In 2016 and 14, there was very good weather with lots of release from organic matter. And in this particular location, the soil had quite a bit to release. In the wetter years where some of that was lost, more fertilizer was needed to get that corn up to its potential. So the weather has a lot to do with it, and it changes a lot year to year. And what you saw this year doesn't help you much in making the right decision for next year. Another thing that we've seen in our research is that the most profitable rate varies from field to field. We did 8 full-length nitrogen rate strip trials, and what we found was that in one of the fields we could get by with 88, and another field we had to have 199, and so the average was 136, but there were fields that were 50 or 60 pounds off from that average in terms of if you're putting the same rate across the whole field, what was the best rate to apply? And then you go in and look at the within field variability. I'm going to try to explain this quickly, but it's a little difficult to. But each of these colored rectangles is its own separate nitrogen rate experiment. And so the one in the southeast corner that's got the yellow square with a circle around it, the graph here shows the response with 0, 50, 100, 150, 200, and 250 pounds of nitrogen. And the rate that made the most money was 140. You couldn't make more corn by going above that rate at that spot in the field. But there are other spots in the field where you could make more. So wherever it's yellow, the farmer's rate, which was 150 in this field, that rate was pretty good. Where it's pink, farmer's rate is probably 30 pounds low. Where it's red, the farmer's rate was 75 pounds low. Where it's green, the farmer's rate was probably 50 pounds high, and where it's blue, it was 100 pounds high. So the rate went all the way from 0 to 250 in this field. There were places that those were the rates that made the most money. So all over the place, and if you put the same rate everywhere in the field, you're going to have both under and over application. We're not the only ones who have made this kind of a study, and this is not the only field that we studied. We had 8 and 7 were as variable as this one. In Minnesota, Kansas, and Pennsylvania, other people did research showing similar outcomes. A fairly limited study in Wisconsin did not show a lot of variability, but overall, what is out there in terms of science suggests that within field there's a lot of variability from place to place, and if you apply 150 or whatever the rate is in your area that's normal, you're probably going to be both over and under in parts of that field, and that's how you want it. You don't want to be over in the entire field or under in the entire field, but going variable rate is going to be better if you can get the places that need more correct and the places that need less correct. And the only thing that I've found that's really good at doing that is using the color of the crop to evaluate how much it needs and how much the soil is supplying. So if you apply part of it pre-plant and put a full rate somewhere in the field, that's a reference to see what color the corn should be. And we know right where it is. We can then create a a rate control file based on crop color that will put more nitrogen where the soil is supplying less and the crop is showing it, and get it caught up, but allow you to cut back where the soil is giving a lot of nitrogen and the corn is a darker green color. Here's an example from 2016. MFA is our biggest co-op in Missouri, and they did this demo. And so there was a high nitrogen reference area in this field. Let's see, I'm trying to get the pointer now. Okay, it's right about here. And the fact that you can't see it means that the corn right next to it that's only half fertilized is getting quite a bit from the soil and doing pretty well. If it stuck out like a sore thumb, you'd know that the soil wasn't giving much and you better get some fertilizer on there. So based on this photo, we made the rate control file, and you can see it's higher in the northwest corner, and it's fairly subtle that it's lighter. The corn is lighter there, but if you look closely, your eye will probably say, yep, it is. We put that control file into a high clearance spinner. MFA didn't tell me at the time that they hired me to do this field, but we were going against Field View Pro in that field, and we recommended an in-season application that gave a total of 141. Field View Pro was a little bit shorter on that and came out a few bushels shorter. And they actually did this in 12 fields, and we ended up being 4.5 bushels ahead of Field View Pro, averaged over those 12 fields. And the timing is still an issue with this because we really can't, with a satellite, see individual plants. So we have to have the soil more or less covered up. Hip high is not quite covered, but it's good enough. By the time it tassels, you probably shouldn't get images anymore because the tassels can mess up the image a bit because they'll be out over half the field and not the other half and change the color. If we get to where higher resolution imagery is widely available, we can go earlier, at least as early as knee high with the same approach, but the imagery resolution is holding us back at this point. With satellite, we had a day and a half last year compared to 4.5 days with the plane, but with satellite, we're going to get that down to an hour, I'm pretty sure, at some point in the next year or so. So thank you very much, and it's time when we can open this up for questions or comments or discussion, what you've seen, what you think.
Great, Peter, thank you for that. Okay, so I'm going to change the screen real quick, and so as your questions are coming up, please go ahead and enter those into the chat box. Peter, while we're waiting for people to put questions in, if you could you speak a little bit more about what your next steps are and kind of what you also may need next? What are you looking for in your next steps?
Well, I mean, I think we need to develop partnerships with organizations that can move this into their customers' pocket. As I mentioned, we're working on getting this accessible for people who can apply nitrogen with airplanes. When we can't get a prescription until the corn is hip high and the #1 machine out there that can execute it is a high clearance spinner, you've got about maybe 8 or 10 days to make that happen, and that's a very narrow window. So there's more and more planes that have high clearance capability. There's more and more communication channels to get in touch with the people that have those planes. So I think that's going to be an important part of the equation. I think getting scalable high resolution imagery, and by high resolution I mean like 2-inch, is another thing that would provide a quantum jump in being able to do this earlier. That's what's coming to mind right now, John. Is there anything that you were thinking of that I didn't hit?
No, not really. I just really wanted to kind of get your feel for what your kind of your next needs are. So I think you touched on it. So it looks like we've got a couple questions in right now. So the first, and Peter, I'll just read these and you can answer them one by one as we get to them. So
sure.
The first question is from Jerry. With enough information and data, could a producer model or estimate the amount of nitrogen needed for their fields, or is this kind of thinking a fallacy? What are your
My thoughts on that is that the producer couldn't do it individually, that the complexity is just enormous. The question of whether the the models that are currently commercially available, how good they are is very difficult to evaluate. The data is a little tough to come by, but I can tell you they've bit off a big problem to be able to use that data to really say what happens to the nitrogen. The number one thing that happens to nitrogen is bacteria change it from one form to another, and the forms have very different properties. And modeling what the bacteria are going to do is extremely difficult. And then you add into that what the bacteria are going to do depends a lot on where the water goes, which affects the soil temperature, it affects the soil oxygen, it affects tons of things about their environment, and it's still extremely difficult to get that right of where is the water going. But there's a tremendous effort that's gone into it, and I certainly wouldn't say it can't be done. I'd say it's very difficult to do, and there are people out there tackling it, and they're very smart people, and I think the jury is still out on how good the decisions are. So far, I would say my experience is that so far, I would say my experience is that it works fine. One of the concerns with cover crops, especially grass cover crops, is the potential to take up soil nitrogen, the potential to tie up nitrogen that's applied after you kill them. You know that nitrogen dynamics are complicated by cover crops, especially grass cover crops, and that the uncertainty that is added with the use of those cover crops, that using a decision tool like NVision Ag would be something that would help reduce that risk and help make sure that nitrogen is right in the corn crop following the cover crop. And even if it's only causing a problem in 1 out of 3 fields, figuring out which one that is and getting it fixed is going to be a big benefit for both that individual field and for the whole practice.
So the next question is from Will.
using covers
he asks,
to protect the soil, because people who have a big yield hit somewhere are they're resolved to continue protecting the soil. That way is going to be challenged. And so I think it's a great fit with cover crops or no-till, or and no-till is a bit like cover crops, except less so in terms of altering the nitrogen dynamics. Well, so Will, I would say that it could work with virtually any crop where you're going to apply nitrogen fertilizer or consider applying nitrogen fertilizer. If you look, I mean, maybe I kind of doubt that you really need that this is going to be the thing that helps you decide whether to put nitrogen on soybeans. But for crops where applying nitrogen is a normal part of the routine, I think this can work. There may be crops where waiting for some stress to develop to gauge how much nitrogen you need will hurt them. That's not true with corn. I would say it's not true with wheat or cotton from what I've seen and the research that I've done. But you have to have the research base in the individual crop. So I think it can be done. I think it will be done.
So next question is from Roger.
I have not done it yet.
In one figure with the varying growth tables in a single
it's just a question of doing the calibration research and making sure that the timing and the existence of some early stress is not an issue in that crop.
It
And
also
then
looks like
if you
Barrett
get all
has
those
kind of a
things set
similar
up,
question. So
this
what
can
about
all
nutrients outside of nitrogen?
work
So you might try
to
to
make sure
tackle both of those
in
with
probably most
the
crops, I'm
general
guessing we could
response.
make it work to get the right N rate in the right place at the right time. Yeah, I actually see them as being pretty different questions, John. So I'm going to go with answering Roger's question. And I just flipped through to try to see which field you're talking about, Roger, and I'm not sure, but um, I mean, to me, in the images that I've showed, I would say that nitrogen is definitely dominantly the limiting factor in those fields, but I agree that you have hit on something there, Roger, that where you get something else limiting growth, and it may not be even limiting growth, it may just be changing the speed of growth. You get variations in color due to that. I mean, maybe if the corn is hip high, the wetter areas will have been slower to warm up, and they might be a half a stage or a stage behind, and that means that they're going to be lighter. And that comes into what John asked about directions and where we need to go. One place that we need to go is being able to use some kind of map and a soil map. You mentioned soil type, Roger, and I think soils, if mapped well, uh, do tell you quite a bit about water dynamics and where the water's going, and that can have to do with which parts of the field might be a little ahead or a little behind. And so I foresee that we would be able to take in a map, divide the field into zones, establish the reference color of corn that has enough nitrogen or
Great,
whatever other
thank you for
crop it
that.
is in each zone, and have
The
different
next
yardsticks
question
for the different
is from
zones so that
Jerry, and
uh,
he asks,
if certain
what kind?
places
Oh,
have been
sorry,
held back
Barrett.
by, say,
Oh,
soil
okay,
temperature or
yeah.
even
So Barrett
dry
asks,
soil,
what about nutrients
that
outside of nitrogen?
we have a
Kind
high
of.
nitrogen reference in that zone that tells us, okay, this is the best it can look in this zone, and maybe it's better or worse than in a different zone. And we're really going on isolating on nitrogen more by doing it that way. Well, we missed Barrett. And the answer is there aren't very many fields out there that you get visual deficiency symptoms in, except under unusual weather conditions. Like I see potassium deficiency when it's quite dry. Occasionally you'll see potassium deficiency when it's quite wet. It's on the bottom leaves of the plant, and nitrogen often is too, but nitrogen often goes all the way up the plant, and potassium really never does. So looking from above, potassium is not likely to interfere. I have had one field where I looked from above and thought that's kind of yellow, and walked into it on the ground and saw that it was sulfur deficiency, but uh, that's out of, I don't know, 500 fields I've gone into, and when I thought it was nitrogen, it was. Now, part of that is I've tended to be above those fields and then go into walking into them when it had rained a lot, and I would expect nitrogen deficiency. Rain also washes away sulfate, so it wouldn't be a surprise to find sulfur deficiency, but I just have not found that very often. Um,
Okay,
if
thank
I
you for
was in the
that.
Great Plains where
Okay, so next question is
iron and
from
manganese and so
Jerry,
on
and he
can
asks, what kind
make
of
corn a yellow
resistance
color, I would
objections,
want to be
if any,
careful
have you gotten from producers?
about
So I'm wondering if
interpretation
this might be an
of the
adoption
images because
question.
of those nutrients. But if you're in an area where you're in acid soils and micronutrients really never do that, I would say that a yellow color from the air is usually going to be nitrogen a great majority of the time. Yeah, well, I think that the number one resistance or objection has been turnaround time. which is why I'm pretty excited about the satellites. I know I've had a number of orders canceled because they placed the order and it was 4 days out and the airplane hadn't been able to get a picture
Okay,
yet,
thank you for that.
and
So next
they
question is
needed to
from
move.
Phil,
And sometimes you need
and
to
he
move a lot
asks
sooner
what
than
form
that.
of
There's a system
nitrogen
coming through.
do you recommend
You can
using?
get your machine through the
How
field
about
now. Who
ammonium
knows
or
how
ammonia
many days you'll
sulfate?
be stopped, if you get the rain. And so getting the nitrogen applied, getting that management done is more important than the quality of the decision in terms of rate to people at that point. So that's been the number one sticking point, I would say. Well, Phil, thanks for the question. It's a great question, and I don't know the answer in terms of ammonium sulfate. I've never actually thrown ammonium sulfate over the top of corn. I've talked to a couple people who have, and at the rates they're using, which is probably less than 20 pounds of sulfur per acre, they say it works and it's good and it doesn't cause a problem. Uh, I haven't done it myself. Uh, you know, you can't broadcast solution on big corn or you can torch it. But other than that, you can drop solution between the rows and that works very well. I know quite a few people actually who have machines that will inject it between rows, even on tall corn. Uh, Broadcasting urea is the fastest, whether it's from a planer or a high clearance spinner. You can really get a lot of acres done that way. And our research shows that even with high rates, we were getting very little yield penalty due to the burn. You get some burn, you look at it, you don't like looking at it, but we did not lose many bushels at all. I think even at 150 pounds of actual N on 4-foot tall
Okay, thank you
corn,
for that. So
we were
next
looking at 4
question is from
bushels
Johnny,
penalty.
and
And
he
when you really
asks,
need nitrogen, that's
so
not
he
much of a
says
penalty,
runoff
and you're
is a
getting
hot topic in the
a
Great Lakes
45
region.
bushel response to it.
Any ideas
So,
on use
so urea
in this
over the top
capacity?
works pretty darn well. We did screen our urea and do it after the dew was off the leaves. So I think the possibility is there that with dusty material, you could get into more trouble. But really, any of those works just fine. Well, Johnny, the way I understand it is that nitrogen is not a big deal in the Great Lakes. It's the phosphorus that really gets the algae going. And I do have a great idea of how we can um, reduce phosphorus going into the lakes without sacrificing any bushels. It has to do with on-farm
Yep,
testing,
nope, you're
strip trials for
still there.
P,
We're still with us.
and I think it's very doable, and we can identify where we actually need the fertilizer and making money on it
Oh,
this
go
year
ahead.
and where we're not. But my understanding is that nitrogen makes algae grow more when it hits salt
Okay,
water
thank you for that.
because the
So
salt
next
water has a
question
fair
is
amount of
from
phosphorus
Will.
in it.
Can you talk
The
more on the influence of soil type
fresh
using your
water is
tech?
phosphorus limited, and so you add nitrogen to it and nothing happens. Am I still on? My computer screen went black. Okay, great. So I don't think this is going to help the Great Lakes, but I think it'll help the Gulf of Mexico. Yeah, thank you, Will. I think especially on fields with a lot of variability in soil type, I mentioned this earlier, we really do need to get our system modified so that uh, we just do it by soil
Okay,
type,
thank
that
you for
we
that.
try to have a
Okay,
reference.
so
If we're
looks like
doing
a
a
couple
plant
questions from Roger in
application,
a row. So
especially,
next,
I mean, for rescue,
I
I
know
think,
if I know folks are
you
interested,
expect
can
the
you tell
lower
me how
wetter
to
soils are going to
access?
lose more and need more, and
What's
we
the
would continue
cost
to
for
do things
like
exactly as
200
we do them
acres?
now. But if you're not looking at a loss situation, you're looking at, we're going to manage our variability out there. We would do a better job if we were looking at what does nitrogen-sufficient corn look like
Yes,
in
yeah,
each of the
yeah.
soils in the
We'll have
field,
that.
and
We'll
use
have
a
the
different
slides, and
yardstick in the different
yeah,
soil
you've got a
types.
couple at the end, I think, that talk about.
Okay, Roger. The What'll go up on YouTube will have the whole slide set in it, right, John? So there's some slides. Um, right. So here's one. You click on place and view. You go to the NVisionAg.com. You click on place and view orders. Then you click on add. You put a field name in and click on add field. Then you click on view field. Then you um, in this left window, you choose files that have the boundary and upload them. And then I didn't have screenshots for the rest of these, but you pay for the image. Then when you get it, you look at it and say, okay, do I need to do anything? If I was trying to decide on rescue nitrogen and it looks fine, you may be done. If you're trying to make a decision about yes or no on rescue nitrogen, you may order a yield loss map, which is a separate but very simple and immediately returned product. And if you know you're going to do it, you don't need a yield loss map. You can order the rate control file. And again, it's you have to tell it what fertilizer you're using and your floor and your ceiling rate. And then essentially immediately it makes the application file. And the only time there's a couple of minute delay in making the application file is if you're, right now we do it on about a 65-foot grid. And if you want to change that, we have to go through the calculations for the whole field again, and that'll take a couple minutes for most fields. But other than that, it's pretty much immediate. So, and the cost for 200 acres, it's $1.50 per acre for the image. So you're at $300 for a 200-acre
Okay, thank
field
you for that.
to look at the
So
picture,
one more question
and
from
then
Roger. Have you
it's
tried
$2 an
comparing
acre
this
for
with
either the yield loss
other
map or
rules
the
of
rate
thumb,
control
like
file.
put 50
There are
everywhere?
volume
I
discounts, there are
remember
early
you
order
talked about that a little
discounts.
bit.
It's all on the pricing page on NVisionAg.com. But if you're going to do a planned application on 200 acres where you wanted the picture and then a rate control file, and you knew you were going to apply nitrogen because you're only half fertilized, you'd be looking at 3.5 an acre, which would be $700 for that field. Yeah, Roger, I have in the places where I've done rescue experiments, I've done 50 and 0 and then a high rate. And from that, I can say, okay, how did 50 compare to doing nothing? How did 50 compare to making a full yield here? And looking over all those, I would say
Okay, thank you for that.
I can make the
So
person
next
who's in
question
a
is
wet
from
area,
Will.
and
Are you looking
the
at using
alternative is
drones
do nothing or
versus
use this, we can make
satellites
them over
or
50 an acre,
planes?
over
I guess
$50 an
other
acre.
types of
For the person who's going to put
delivery to get
50
your imagery.
everywhere, my estimate is it's about a $20 an acre benefit to fine tuning that, putting the right rate in the right place. And that may include that the right rate is 0 in some places, and other places it might be 150. And I think that doing that as opposed to a flat 50 everywhere, we can make them about $20 an acre. Yeah, thanks, Will. We can use all three. Um, the drones actually make it possible to go earlier in the season. From my point of view, scalability is the issue with drones. Uh, and right now, the only way we have to run a drone image is for you to somehow transfer it to me, which would probably have to be something like Dropbox or something like that. And then I can put it in. We have not yet built a portal for people to put in their own images that they acquire. We assume that we're going to acquire the image, but we can do it. We've done drone images, and planes were all we did for the first 2 years, and we're doing satellites now, and we're developing. We're working on a a range of different satellites so that people that have access to different satellites can use us. We are focusing on the Planet Lab satellites because of the frequency that they're getting images with, and that makes the timing work better. Of we can turn this around fast and get people out there, running in the field with their machines. But any of them will work if you can get a drone image. We can do this on smaller corn, and the question is how many drone images can you get, and who's running around getting those. I am working with a guy locally here in Missouri who is saying that he thinks he can do a lot of fields and he can do them for $1 an acre. But honestly, I mean, if he needed to do 80,000
Okay, great.
acres,
Thank you for that.
there's no
So
way he'd have
looks like our
the
last question is from Phil.
capacity to get
And I
that
think
done in
he
the time
asks,
frame it
is
needed
there
to get done
any
in. It can
difference
work for
than
a
canopy
handful of people trying it for the first time, but I don't
reflectance
think it can work as
sensors?
a
If
big
so,
practice
how?
unless we get a lot of people out there running them, or unless we get to where the drones can cover a lot more acres before they have to land, and getting out of line of sight. And I know there are people working on that. I believe it's probably going to happen. I don't know when, so we may have a different answer to that question at some point. Bill, the answer to that is that it's the exact same concept, and the differences are in the details of the mechanics of carrying it out. Uh, one advantage of the canopy reflectance sensors is you just go out now, and unless it's too muddy out there, you can do it under virtually any conditions. I think we're going to be able to catch up to that with looking for yesterday's satellite image, and if we can turn it around in an hour from the time you place an order until the time you have a control file in your hand, and I think that's nearly within reach, that when we can do that, that advantage for the sensors will be largely gone. One disadvantage of the sensors is you don't know how much you're going to use while you're in the field, and for a lot of these big machines that cost a lot of money, you want to stage them very efficiently, and maybe you don't want to send it to the next field that's applying the same exact product. You want to send it to the closest field when it finishes this field, and maybe you're going to use it for some other material. So what you'd really like is to exactly empty the hopper or the tank if it's a sprayer, and you can't do that with the sensors. You don't know how much you're going to use until you're done. Whereas with this approach, you get a load ticket and you know how much to put in, and then you're done and you can go to the next field and do something different. I mean, maybe someone wants a sulfur blend in the next field and they didn't want that in this field. So, so that's an advantage of the aerial approach. And another thing with the sensors is, well, I think there are limitations in what's available commercially that could be overcome and just haven't been. One is with the green seekers. You know, after 2 hours, well, they always give a lower NDVI in the middle of the day than they do in the morning and the evening. So if you measure a high nitrogen reference area and then you start fertilizing, if you're in a big field and you go for 2 hours, you could be off 70 pounds from what you were 2 hours earlier on the same corn. And so you really need to check high-end reference areas fairly often with the canopy sensors. And I am not a big fan at all of the Optrix from Ag Leader of the virtual reference concept that they use. I've had too many fields where it was a big failure. And so I think both of those things are things that those canopy sensors, the reflectance sensors, those can be overcome. They just haven't been yet. So
Okay, I'm changing the
so the
screen
one thing
because I
that
think we're
they
about
can't
to
do
wrap
is
up
know
the
how much nitrogen they're going
presentation.
to use on the
So
field, and
we've got a couple
with
poll
an
questions
image
up.
that's taken
So
it,
the first couple
boom,
were what we
we've
opened
got it.
with, and they're
We make our
the
recommendation, and we know
latter
how much
two,
fertilizer is needed for
questions
that
3 and
field.
4. So if you take a
That's
moment
an
and
advantage
take a
for
look at
the
those and respond to
aerial
those. And
approach.
Peter,
And
in wrapping
the
up,
disadvantage is waiting for
any
the image, and
parting
if we can get
thoughts
rid of
based
that,
on this
we'll be
discussion or other things that didn't get asked
probably
that you thought might,
a better
that you want to pass along to
logistical
our audience?
choice than the canopy sensors.
Okay, well, so with that, for you in the audience that are still with us, if you would like a copy of the recording, so if you scroll through the chat box, and I'll leave this page up for a while, the our YouTube page is up there. You can also send me an
Oh,
email
nothing's
if you'd
jumping to
like to do
mind, but
that.
I see Phil
And
Calkins
so
said,
again, I've
thanks,
posted the link
Dawkins there.
there.
Thanks, Phil,
And
for listening
closing
in.
up the webinar, I want to
Appreciate it.
say
And
big thanks to our presenter,
you and I have had
Peter
some
Scarf from
good
the University of
conversations over the
Missouri.
years.
Peter, this was a great presentation, and I really appreciate your effort. So thank you very much. Great. Well, thank you very much. And thank you in the audience for participating. And with that, we will close the webinar.